Okay, so you're graphing these two on your calculator, see what the zeros are and the behavior. So I truly only care about those things. I don't care how high or low it goes. I just want to know what the zeros are and the end behavior. It is so cold in this building today. All right, my window's a little weird for this, and I still can't see all of it, but I'm not mad about it because all I care about is end behavior and zeros. So if you can identify end behavior and zeros, then you're all good. Remember, zeros are second trace 0. The left bound and right bound can be a little funny because you might not see your mouse or your little cursor. So make sure you're really like on the negative side or the positive side, whichever one you need to be on. Or else it might tell you there's no change and it'll be mad about it.
You want to know the zeros and what?
End behavior. And you can look at your graph to know end behavior, or you can look at your equation. Is this positive or negative? Good, even or odd? Odd. And again, you can just tell from the x to the third is positive, odd. Also, it doesn't like come back down, it goes up. Hey Jane, you can sit anywhere up in the front. And so I'm gonna graph my positive, odd, and all my zeros. So.
You can tell it's odd just because the x has 3.
Because the x has 3, yep. And if you need a calculator, let me know. You should need one, but if you want one, you can have one. Thank you. $11, 1, and -5 are the zeros I found for the first one. Reminder, when you just sketch these graphs, I don't care how like high or low your like peaks and valleys go. That doesn't really matter to me as long as you like cross out all your zeros, as long as your end behavior is the same. So once you think you got this one, go ahead and graph the next one, see if you can do the exact same thing. second one, I got my zeros to be -6, 2, and 8. And I also have it being positive on. So it should look very similar to the other one, just different zeros. All right, how are we doing with that? A little reminder, calculator, zeros, and behavior, sketch and graphs. Okay, we're gonna move into 2.4 then, if you guys are ready. 2.4 is helping us, we're all kind of like leading up to 2.5 is kind of like the big end point of this section of this chapter. And these are kind of pieces that are helping us along the way. So graphing is helping, we did some factoring, we did some calculator stuff. Now we're gonna go down and we're gonna get into some polynomial division. You guys remember doing division with your Algebra 2 teachers a little bit? Okay, I'm gonna treat it like you haven't seen it for a while, so we'll go kind of slow through it. And there's two ways that we can do division. I don't need my calculator anymore, so I'm gonna get rid of that. We can do long division and we can do synthetic division. Now, I think synthetic division is technically easier, so we wanna start with the harder one. Long division though reflects what we did back like in, what was that, 3rd, 4th, 5th grade, whenever we learned long division of actual numbers. So I'm going to take the second part and I'm gonna put that on the outside of my division sign. I'm gonna make a big division and I'm gonna put the first part underneath the division bar. Now, I need to make sure I've got all the pieces. So I have an x to the third. I have an x squared. I don't have an x, so we need to fill in that space with a 0x, and then I have my constant. So if you're ever missing any of the little pieces, so I started with x to the third, I need to make sure I have an x to the third, an x squared, an x, and a constant. Okay. So we're set up like this. Everybody good so far? Okay, I now ask myself, okay, what times x is going to give me x to the third? That's what's going to be x squared. Right, Pam? Thank you. Okay, so x to the second times x is going to give me x to the third. And we got to make sure that we multiply that x to the second by both things here. So I multiply by x and I multiply by -1. So then I get negative x squared. When we divide, like when you did long division as a kid, you would minus them. We're gonna minus these same things here. We're gonna switch our signs. So I'm gonna make that negative, and I'm gonna make this positive. So that gives me my x to the thirds cancel, and I have 5x squared, and then we carry down the next term. So we changed our sign so that my first term canceled out. If your first term doesn't cancel out, you did something wrong. Cool. Carry down my 0x. So carry down my plus 0x. Now I've got a new term that I'm looking at. So now I ask myself, okay, what times x is going to give me 5x squared? 5x. And just like we multiplied x squared by both the x and the -1, we're going to multiply 5x by both x and -1. So that becomes 5x squared and then minus 5x. I like to switch my sign and draw my like underneath part at the same time. So it's like all of these slashing together, switch all my signs. So now I can cancel out my 5x squareds. And I have just 5x. My last step is to carry down my -2 and do it all over again. So what times x is going to give me 5x? Good. So I'll do 5 times x is 5x, and then 5 times -1 is -5. Gonna switch our signs. And so I get 3. Now there's nothing else to carry down. So 3 is technically my remainder. So sometimes your teachers will show you like put an R3 next to it. I'll show you the official way to write it too. Anybody have any questions on what we've done so far? Okay, so my final answer is gonna be x squared plus 5x plus 5. So I just copied down what I had on top of my fraction bar or my division bar. And then in order to account for the remainder in like a grown-up math way, we don't write little R3, that's like an elementary way. We write it as 3 over what we were just dividing by, x minus 3, because I just can't make that any smaller. If there's a remainder of 0 or there's no remainder, that means it divides evenly and that's actually perfect. But these first few examples we're doing, that's not the case. All right, how do we feel? Okay, good. All right, let's do another one together. We got another long division. This one is weird though because I'm dividing by it. It's going to be 3 terms when I take it out because it's x squared minus 2. I have to make it x squared plus 0x minus 2. I need all of that outside the fraction bar, outside my division sign. And then 4th, 3rd, 2nd, 1st, 3rd. Okay, I'm all good here. I just copy everything down. I don't need to have any placeholders because there's nothing missing. All right, so now I'm going to ask myself, okay, what times, this time it's times x squared. What times x squared is going to give me x to the 4th? X squared? Mm-hmm. X squared. And then I have to multiply x squared by all 3 of those things and put them under the next 3 objects in my division. So I've got x to the 4th, I've got plus, and that's like 0x to the 3rd. It will always be 0, but you can make it keep holding the place. And then minus 2x squared. One more right this morning. All right, we got to change all of our signs. So that becomes minus. It truly doesn't matter what the 0 sign is because it's just going to carry whatever the top one is, but you can make that minus if it makes you happy, and that will become plus. That gives me my x to the 4th cancel out. I get 2x to the 3rd, and then I get negative 2x squared. Carry your x. Hanging in there so far? Okay. All right, so now I ask myself what times x squared gives me 2x to the 3rd. I heard it 2x. Anybody have questions on how I know what to put up top? You just being shy this morning? Okay, that's fine. I just want to make sure. If you really don't know, you gotta let me know. All right, so that becomes 2x to the 3rd plus 0x squared minus 4x. Change all my signs. So my 2x to the 3rd cancel. I get negative 2x squared plus 5x. Carry down my negative 3. All right, last step, what times x squared gives you negative 2x squared? It's negative 2. So I multiply negative 2 by the whole polynomial on the outside. I switch all my signs. And so I get 5x minus 7. Now I've got nothing left to carry. So this whole thing, 5x minus 7, is my remainder. Normally it's just one number, But because I have like this trinomial on the outside instead of a binomial, I have like an extra term here and I have nothing else to cancel it with. So my remainder is 5x minus 7, and we're gonna write it in the nice official way. My answer is x squared plus 2x minus 2. And then I'm gonna say plus 5x minus 7 over, and the denominator is what I had multiplied on the outside, x squared minus 2. Kind of a weird one, but we doing okay with that? Okay, those are all the long divisions I have to practice right now. We're gonna do some synthetic division. Do you remember doing synthetic division back in Algebra 2?
Yeah.
Okay, it's a weird process, but a lot of times I find students like it easier because it's easier. I think we can get these two done, and I think we can go to lunch, so let's do that. Synthetic division is you take the last part, but instead of putting x minus 2 on the outside of something, I build a little house and I switch its sign. So instead of being x minus 2, it's just going to be a positive 2. That's what it is factored out. I take all my coefficients from my terms up front, so it becomes 2, 4, negative 1, 1. If I had anything I needed to hold a place for, I'd throw a 0 in there, but I don't have any in here. I draw like a little line because now I'm going to go above and below it. So I carry that 2 down first. And then to put the number under the 4, I have to do 2 times 2, so that becomes 4. You add them together, so whatever sign it is your operation. So we're just adding those. That becomes 8. 2 times 8 is 16. So negative 1 plus 16 is 15. And then 2 times 15 is 30. And 1 plus 30 is 31.
You multiply the 2 that are on the bottom, right?
Mm-hmm. Yep. So I take the row on the bottom, I multiply it by 2 to get the number on top, and then I add those to find my new number at the bottom. The last number, so this 31, that's your remainder. In a perfect world, that would be 0, but it's not. Everything else, you take the exponents and you just drop down 1. So I started with an x to the third before, so now it's going to be 2x squared plus 8x plus 15. And then my remainder is 31, so we'll make that 31 over x minus 2. We want it to be 0, and later today we will get it to be 0, but it's not there yet. All right, you want to try the next one on your own? All right, I want you to take a minute before you get too deep in your problem. Make sure that you have 2 zeros. You got to hold the place twice. We have an x to the fourth. We have 5x to the third. We don't have any x squares, and we don't have any x's, but we do need to hold their place. We do need zeros in there for them. So make sure you adjust and have that, and then carry on. -1, 4, that means my answer is x to the third plus 4x squared minus 4x plus 4 plus negative 12 over x plus 1. All right, not too bad, right? Yeah, we had to learn these skills because we're going to use them in a different kind of context for the rest of today and the rest of the week. It is time for lunch. Be back ready to go at 12:20. I'm starting at 12:20 whether you're ready or not. Have a good lunch. Which questions do I need? Did, just these two on the calculator. I think everything else you had done. Yep, yep. All right, we're going to lunch. We'll be back.